Thank you. So my talk today is on that's not it. This is it.
There's a microphone
There's a microphone
that you can use. If you talk into it, people can
If
hear
I talk into this?
you. Yeah, people can hear
Nope. 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 There we go. Why did I think that this was not a thing? Okay, so backing up. If you've been here the last 2 times, this would have been accurate. So we're changing it up a bit. So the talk today is about home automation, smart homes. We'll talk a bit about what that means later. A fair bit of content. I'm going to run through it, and it's going to be mostly about my story, about being really disappointed with what I pay for, and then doing something with that. So a little bit about me. There's nothing so cold, unforgiving, so dark as the mathematicians. My background is in math. I have no formal training in my day job. I work for the city in the innovation department. If you have a problem with anything regarding to the city, I have a thing immediately after this and won't be here. So that's fun. And contrary to popular belief, I can talk about things that aren't Amazon. Shut up. So today's talk is going to be about one particular trench. It's going to be about my experience with my particular home automation system that I picked up. And it was a good deal at the time. And I thought, hey, this will be great. And it turns out it was okay, like satisfactory. Like if this were grade 2, it would be like satisfactory in terms of plays well with others. So quick poll, how many people have, and define it however you want, smart home, home automation, something like that? Pay for it or don't. Okay, so a third-ish, give or take. How many people subscribe to a smart home or automation or home security or something? Awesome, like 6. Okay. So home automation, I'm going to split it into a couple of categories just because it's convenient, and that's really going to be about it. So the first category is just garbage one-offs, things where people have no business making this stuff. Like I'm talking about fridges and freezers. Like no, you make a cooling thing, let someone else make your smart home thing. You have no business in this space. And they don't interop well, their cloud services shut down, insignia. Right, and so now you just lose functionality for a thing you paid for. So like this is stuff that should not exist, and yet it's just so common. The next one is good one-offs. You know, things where any one device is kind of worth buying. You know, your Alexas, your Google Homes, your begrudgingly, I'm going to throw Logitech in here because their stuff works, but you only need one of them, right? You need one Logitech remote. That's kind of their thing, and you only need one, and so there's no point in having 2. And this is where one device is worth it, but the rest isn't. And then the third category is where just having more is better. One is pretty much pointless, but you throw half a dozen in there and it's worth something, right? So this is what I end up with. I've got probably half a dozen or close to a dozen different things, and you subscribe to your Fluence or your Vivint or even your normal alarm companies are starting to get into this, where it's a curated space of tools and things you can subscribe to, and they're guaranteed to work together. And it's one app, it's one pane of glass. It's supposed to be really nice. So smart devices themselves, and the platypus is up here because, and you can't really even see that, because taxonomy be damned, how dare you try to categorize me. So smart devices themselves split into 2. One is proprietary cloud. This is, you have to have their cloud service, and if they don't run it anymore, you are screwed. Insignia, again, right? They're great while they work, and if you're not paying a subscription fee or you're not receiving advertising, that service is likely to die unless there's another revenue stream that pays for it, right? I bought my Echo once. I don't receive advertising on it, but I pray to God that the advertising and the extra stuff I pay Amazon for pays for that ongoing subscription service. I buy a smart TV once that depends on a proprietary cloud service. They don't have another line of business that's going to front the bill for that ongoing subscription service I'm not paying for. So it's important to think about a bit of the economics for your provider to figure out whether or not what you're buying is going to work in 5 years. The other one is the open device connectivity stuff, right? It's your Bluetooth, your Wi-Fi, your LoRa, your whatever, your Zigbee, your Z-Wave, where at least it's a known commodity. I know how to talk to this thing. I can buy a bridge for this thing. Everyone can talk to this thing, and I can just make it work. So these are nice. Sometimes it's a mix of the two in an ecosystem if you're subscribing. So Vivint stuff is all Z-Wave. Some other stuff is Zigbee. Some stuff is Bluetooth. Some stuff is Wi-Fi. So sometimes you'll get things you can work with, either through Homebridge or something like that. Lots of times, though, you don't. So this breaks up into two categories. I don't know why it does this. This is weird. Open and accessible, things where with some intent, the manufacturer says, yes, please work with my thing. And they with some intent, allow you to do that. Maybe it's through a proprietary tool, but at least it's a tool they make available. Maybe it's through adopting an open standard or an open communication process or something like that. And then the other ones are just not that. You have to use our pane of glass and our service to talk to our stuff, and that is the end of this story. And this is what that's what I was dealing with. So my story, 60 seconds or less. Step 1, get a smart home with device ecosystem. This should be great. I pay for the alarm system. I don't pay for any of the stuff. Awesome. So I lived with it for a bit. Call it about, I got it in the winter, so I lived with it for 8 or 10 months and then went, interesting. I want to do something. I want to know what the history of my house temperature and humidity is. It runs my thermostat. I would love to see the history and how often it's cycling my air conditioning, how often it's cycling my furnace, because those have certain efficiency windows. I'd love to see that. So I try to do the thing. I can't do the thing. And I get sad because it's collecting the data. I can see it in the app, but it's only providing me the instantaneous value right now. And I realize that this is an arbitrary decision they've made. For no good reason, this is just something that they've decided they aren't supporting. It's a function they don't provide. Even though they're so close, they just don't do it. And it turns out this happens over and over and over and over with this platform. They're collecting the data. They don't make a certain way to work with the data available. Disenchantment ensues. Does anybody actually watch this on Netflix? It's hilarious, eh? So that's my story. So this is going to be a bit of a tragedy in about 5 acts for large values of 5. So the motivation is, I have a Vivint system at home. I want to track temperature and humidity. This is the first use case. I want to be able to stream video clips to long-term storage. Currently, it only records clips on specific events. I want full streams because the clips don't always trigger when I want them to, or it's not good, And I can't do that out of the box. So the ultimate goal is, I'm just going to read from the slide here, be able to have flexibility of integration, bridging, and longevity of support that I get from an open system with the phone support and guaranteed compatibility of the Vivint ecosystem. I want the best of both worlds. So we all know I'm not going to get there, but a little bit along the path would probably be good enough for me. So this is only about software. I'm not like, JTAG, is that a soup? I don't know, right? Like opening up the hardware is not a thing. I'm not going to start soldering anything. I'm not going to do that. I am likely to electrocute myself or my cat. One of the two. So this is entirely a software endeavor. If you want to talk hardware, Troy can do a talk next year. Right, Troy? Awesome. So how are we going to do this? How are we going to skin this snake? So I know Python. So I'm thinking a Python module that lets me interact nicely with some of the stuff. I'm going to have to do some science. I'm going to have to do build some hypotheses, test them, trial and error. That's going to be the dominating mechanism by how I achieve this. Science is just magic plus underwear, right? Like that's just, you put on underwear and you do magic and you get science out of this. So that's how this one worked actually. So Act 1, the network. Nmap and TCP dump, all the things. So the general architecture of how this works is, and I'm going to draw with a laser pointer. There's the internet over here. There's the Vivint panel over here. And then there's all the devices that connect to the panel. And then the panel connects out to the internet. That's how it works now. It used to work differently, and we'll get into that, but that's how it works now. Everything runs through a panel that's connected to my wireless. So I own the network. I can stick whatever I want between the panel and the internet. Or in this case, I can just Nmap and scan the panel. I can TCP dump on the panel. That's really interesting. Actually, there's a ton of listening services. If you want, it will happily be your recursive DNS resolver. Hands up if that one makes sense. So that's because it's running DNS mask to run its internal Wi-Fi access point for the high bandwidth devices like cameras. So it's running DNS mask and it's just not filtered for the rest of the network, even though it should be. It's listening on the RTSP alternate port. And it speaks primarily HTTPS and OpenVPN on UDP, if it can, to home. So the vast majority of the panel's traffic goes over OpenVPN. It doesn't make any attempt to hide it. The rest all goes over HTTPS. It bootstraps itself over HTTPS and then dumps down to OpenVPN for the rest of the communication. Makes sense, I guess. Fair enough. All right. And this is the key one. We use it later. Clients, if they're on the same network, so, well, my phone's busy. So my phone, if I'm on the same network as it, it will attempt a peer-to-peer connection with the panel. It won't always route through. So phone, panel, it won't always route through the cloud. It doesn't always do the big ass horseshoe. It will sometimes just run directly laterally, which is useful. We exploit that later. So network history, cameras used to be directly connected to my Wi-Fi. Call it a year ago was when I noticed this. And they had open RTSP ports, either the primary or the alternate, don't recall. But they were listening on RTSP and you could just connect to them. It was all authenticated, but they were there. And then suddenly they weren't, right? They're not there anymore. And I noticed another hidden SSID. So what happens is those cameras speak Z-Wave to the panel, and the panel was able to reconfigure them over Z-Wave and say, hey, BT dubs, don't talk to this AP anymore, talk to this other one. And it pushes out its communication over Z-Wave, which once you've paired two Z-Wave devices, they share a key and you can't get into that connection anymore. So I'm not here to start digging into those protocols. This is just purely things I can do without cracking open hardware or making my own. So that happened through a firmware update. Super interesting. We'll get back to that. So step 2, browser apps. I can use my phone app or I can use vivinsky.com/app or whatever it is. The dev tools, F12 is absolutely your friend. This got me 95% of the way to what I wanted to do. I just would do something in the web app and then I would watch what happened in the browser and I would reverse engineer it. And the results of that are really interesting, right? It's reasonably restful. It's reasonably well architected. It's all JSON to and from. I mean, it's all minified JSON. It's completely unreadable. So it's all about diffing it and figuring out what this means. And there's lots of integers, things like state equals 0, not state equals cooling or state equals off. It's state equals 0. There's no excuse for this other than trying to obfuscate things because it's not like you're saving network bandwidth, right? Like, come on. So, but that got me the vast majority of where I needed to go. All right. Once I was authenticated, I could do the thing. Authentication left to be solved. So we back up and we move back to authentication. This one was a huge pain in the butt. This one was really frustrating, right? So there's almost always, and I looked at a couple others, there's almost always a third party in there somewhere. So Vivint uses Ping Federate for their SSO for their clients. It allows them to unify their clients, their client SSO, or provide a single SSO interface to their clients and to their internal folks and to different users and different classes. So it was all about how did they do that and how did they expose that to us in a way that I could exploit in an automated way as part of a Python library. The nice part was it's eventually OAuth, which is perfect. It's exactly what I want. I can do that. I did have to parse out some static keys that were embedded in some minified JavaScript with some truly awful regular expressions. But once you get those, they don't change ever. So I imagine that their ping federate key, which indicates them as a client, great, I can use that. So this makes it highly fragile though, right? Having to parse out minified JavaScript with a regular expression, as robust as JavaScript is, I can parse it and do all that. If they change that structure, how they provide that key to the client or change the client-side code that runs in your browser, like this is a highly fragile way of doing things. Again, we're going to come to this. So it works. I can authenticate. I can give my Python module my username, my password, and I can get back a nice object structured way to interface. I can say, hey, give me all thermostats. It says, here's a list of thermostats. I said, hey, thermostat, change the temperature, and my temperature changes. perfect. I can say, hey thermostat, give me the current temperatures and the set points. And I just ran a script that for months on end just would pull that down every 30 seconds. Refresh the token because it expired every 12 hours. Just give it my long-term credentials, my username and password. And it would just keep doing the thing. Beautiful. Awesome. I like it. I couldn't do live video still though, because reasons. Again, we're going to get to that. So, but I could do the thing that I wanted, right? I could interact with the devices. I could arm and disarm the house. I could interact. I could set privacy modes on cameras automatically. I could detect when doors are open and closed. I can get all that kind of stuff all through the API, all without really cracking anything open other than the dev tools in Edge. I didn't use Chrome. I used Edge. And again, since the video devices weren't on my Wi-Fi anymore, I'm like, well, this is a lot of work. I'm just going to skip that. So I skipped it. And man, this is not how I want these slides to turn out. I got to fix this. So now I can infer a bunch of stuff about their architecture. Hey, look. Yeah. So it's interesting because their architecture is split, half on AWS, mostly S3, and the other half on some on-prem data center somewhere. And which is nice because now, if you're really curious, it's certain parts that are more durable, the Amazon side, than their data center side. So S3 is for all their clips, all their snapshots, all their media is generally stored in S3, as well as firmwares. We're going to come to that. That's fun. And instead of things like WebSockets, this was built before WebSockets, so they use PubNub for long HTTP polling for real-time updates. So that's interesting. Ping Federate is their SSO. S3, they do a bit of PGP as well, but OpenVPN is the primary transport for the panel. It's what the vast majority of things go over. So I stick it on GitHub, I open source it, I write some documentation, it works well, I post in some subreddits, I then completely forget about it. It runs, it works, it's running on a Raspberry Pi. I stopped paying any attention to this thing whatsoever. Because once I'd proven that I'd done it, I mean, the mathematician in me says a solution exists, therefore I don't care, right? So I'd proven it was possible and then stopped caring about the outputs. So, right? Of course that's how this works. So, man, this is not... So anyway, fast forward to about 8 months ago, Vivint, remember how I mentioned that was fragile, how I was doing auth? They changed how auth works. It's no longer a JavaScript key. It's not that. Whatever solution I had doesn't work anymore. And that just happened without warning overnight. So this is one of the major downfalls to how I've done this is I don't have an understanding or an integration with them. However, I did get one of the Vivint dev team DM me on Reddit saying, hey, why did you build this? Could we integrate it into our app? Right? So I had a good conversation with them. And of course it went nowhere. I'll avoid the salty language I used at that point, but it went nowhere, which was a bit disappointing because it's like, here's a solution. Please take it. It's free. It's all under, like it's licensed openly. It's not any weird license. So, but I had no idea that it changed until suddenly my thing stopped working. And then again, since I didn't care, I'm like, whatever. If somebody else wants it, they'll fix it because I'd open sourced it. And it turns out that someone did fix it. Right? It actually gained enough traction within some of the particularly skilled folks within different home automation groups that they were using this and depending on it. So open sourcing it and trying to engage with the community at the start built some of that momentum. It was a baseline level of momentum that was key to keeping this thing rolling because someone else reverse engineered the new way they did things and forked it and made the patch and got it working again. Right? That was really helpful because I simply can't keep up with everything that I'm going to do because I have other things to do in my life, like prepare long con talks. So, wow, you cannot read that at all. Great. So someone else fixed it. That means I can keep ignoring it. I can keep completely forgetting about it until they pick this talk for me to do. And I go, I should really do something with this. I need to pick this back up and hello, the return of the motivation. So it's time for live video. It's time for, I want to be able to figure out how to get video, get access to the live streaming. They're just RTSP. This is not hard. Cameras on my network. All right, back to the web app. There's a live streaming video button. I go and I click the button. All right, we're gonna man in the middle of this. All right, so we crack open midden proxy. And again, since I can control Wi-Fi network it connects to, I set up my Raspberry Pi, I throw up an access point, and I move the panel over to it, and it's just a straight layer 2 bridge between wireless and my wired, but now I can straight man in the middle of this thing. Cool, what do we get? So I install the midden proxy cert on my phone, so everything looks like it's authenticated and trusted. Everything works great. I try the mobile app and cert pinning, which I found out is very common with Android apps. Did anybody else know that? Yes. It is a huge pain in my ass. I couldn't get a single app to work. Like janky, weird, like 100 installs total, like weather apps. Nope, cert pinning. So not having built mobile apps, I'm guessing it's part of the tool chain maybe? I don't know. Anyway. Not everything was cert pinned. I did get some traffic through in my midden proxy that was not pinned, and the Amazon requests don't have pinned certs. So the way it looks within midden proxy is if there's a pinned certificate, it's only inspecting the HTTP that goes inside the TLS connection. And since the client is pinning a cert, whenever it attempts to make a connection, it bails before sending any HTTP request. So I crack this open, and you might be able to see. So these green down the side here means that this is an HTTPS connection. And these are all HTTP requests that I'm getting from the panel. What's wrong with this? Not only is it not pinning certs, it's not validating certs. I didn't install the CA certificate on the panel. This is a closed, if you open it, the alarm goes kind of thing. Closed hardware. I didn't install a certificate on this, and I man in the middling TLS connections, and they're still working. Like, this is not okay. Like, what makes you think this is okay? Anyway, that leaves us with two options. So we can either install Flash, or we can install VirtualBox, we can set up an Android x86 emulator, we can get the APK for some super skeezy site, I can sideload the APK into the VM, and then I can grab Frida for runtime debugging, and then at runtime I can futz up the cert pinning. So there is a correct answer here. All right, so I chose option 3 to start. I know there's RTSP listening, we're just gonna see what happens, we're gonna give it a shot. So again, the panel listens on RTSP's alternate port, 8554. It's live 555 streaming media server. It's just an open, it's a standard project. Clearly this thing is built as just on rampant violations of the GPL. So whatever, not my problem. So again, I speculate that the client and the panel, just if they're on the same subnet, attempt to communicate directly. This is my option 3. I have no idea if it's gonna work. Haven't tried it yet. All right, off we go. Fuck. So now we have Nonce digest authentication. So I go to authenticate, the server sends me a Nonce, it says use this, hash it with your username and your password and the realm that I give you and send me the result back. So I can't replay these, I can't really man in the middle of these. It's a reasonably effective solution if I don't already know the password. So I give up. At this point, I give up. So there's really not much left for me to do other than install Flash. So step 1, install Flash. Step 2, take 15 showers. Step 3, get rebaptized because you just installed Flash. Step 4, install midden proxy, install the CA cert, load up the web admin panel, go back, enable Flash through, I was using Edge Dev this time, which is Chromium based, and I think there's 3 or 4 times you have to accept, yes, I really want to enable Flash. Like, I didn't feel like this was the right thing to do. I was wondering if I should just install VirtualBox. Start the stream, success, awesome, excellent, perfect. So the Flash applet is really just there to be an RTSP client, is what I've determined. They're not doing an HTML5 or JavaScript, the Flash is just there to be RTSP. Cool. because what ends up happening is it speaks RTSP to the cloud, which then I guess speaks RTSP back to the panel over OpenVPN. I don't want to know. I don't need more showers. But I can see the API call fly out to the cloud and come back with username and password. It's JSON. It's just username, user, password, blah. So my hunch all along, and Travis suggested that I try to crack the password now that I had the nonce digest auth hashes, and my gut was like, no. So far, things have been done reasonably well. I'm not about to try to crack a password that's probably really high entropy. Lo and behold, I take the password and the username I get, I try them out. Python, I calculate the hash manually. Excellent, it matches the response that I saw fly over the wire between my phone and the panel, which means that the password and username password I got from the API, I now have the API endpoint, all the request parameters. I can fake this using the existing Python library. I can get RTSP credentials to use from a client to the panel. And I know things like here, so RTSP, this is the address of my panel, alternate RTSP port, and this is the video 31 SD. So every camera on your network has an integer. In this case, this was the doorbell was 31, and it's asking for the standard def stream. You can ask for an HD stream with or without audio, all sorts of stuff. Cool. This was essentially, this is not the actually, but this is essentially the password that I got. So I'm glad I didn't try to crack it. I'd still be waiting. So beautiful. All in all, this was a reasonably entertaining exercise, and it reinforced the fact that they're not doing anything wildly offside other than not pinning or not validating certificates when you go to get firmware for the panel. If we flip right back, that's not worth it. That's so not worth it. But that does mean that you can see and maybe mangle, but their mitigation, I don't know why they chose not to validate the cert. Maybe it's just laziness or intentional. They PGP sign it. So it's a signed firmware blob that you can't fake. Okay, fine, I get that. But that does mean that if you're listening for long enough, you can get essentially a firmware dump without needing to dump the firmware. So maybe, I haven't seen one fly across the wire, maybe it's PGP encrypted, but that's also not necessarily great because they're not putting the private key on the panel, they're putting the public key. So I don't know how they're doing it, but it does mean if you watch long enough, you will see every time, and that's true of the client as well. So on my phone, anytime it speaks to Amazon for clips or pictures or whatever, those are all straight man in the middleable. You can feed fake videos back to people on their mobile phone. So if you wanted to break in and you somehow had access to their network, you could do the whole speed, insert a loop in the video stream kind of thing, right? By saying, no, don't worry about it. There's lots of video clips coming back to your phone, but they're all this clip. So you could man in the middle someone's phone. If you knew they were at work and you had access to that, you could provide different clips to them. Because again, those aren't PGP signed. Those are just straight man in the middleable connections. So maybe be on cell or something. I don't know. That's where it gets all super weird. But generally speaking, they're not the worst in terms of security. They don't have any fine-grained access controls. So through all of this, I had to do it with a separate account that had admin privileges to my house. There's admin and not admin. And the only difference is whether or not one of them can make the others an admin, I think. There's no fine-grained access control. There's no real privilege management. So it means that if you're running an automated system like this, you are giving it access to your house or your entire IoT set if that's what you're doing. All these techniques are portable. They should work for any vendor pretty much. It's gonna be really problematic. I don't know if these RTSP credentials ever rotate. I only got them yesterday. So this is very fresh content, by the way. So they may never ever rotate, right? Over the course of a 24-hour period, I never saw my phone re-request them once. So who knows? No idea. So what did we accomplish? We can do stuff now. We can reverse engineer. We can go back through the API. We can scrape data that maybe they are or are not keeping historically, but we can now keep it historically if we want it. We can do it without the apps. We build our own app. If we hate what theirs gives us, we can build our own. It still depends on their proprietary cloud service. But again, in my case, I pay for that as a subscription service. It's unlikely to go away. But if you buy a device and you're not paying a subscription fee, this is the start to reverse engineering, building your own version of their cloud service, right? If for things like Insignia devices that don't have one anymore, you could have your own. This would be the start point. Didn't have to crack open anything. I didn't have to burn myself with a soldering iron. I didn't have to do any of that. I'll leave that for Troy. So these are all value judgments. These are my opinions, no one else. It's not it's not the worst thing I've seen. Like, I've seen worse. So it's okay. It's annoying to work with. It's a huge pain. Some of these are like 150 kilobyte minified JSONs. That's not fun to go through. So diffing them is an important part of this. The panel has way too much listening. There's about 12 different services listening on this panel. I have no clue what they all do. They don't speak standard stuff, and Nmap has no clue. So which means I have no clue. And if Nmap can't figure it out, I'm not going to bother. And a really useful tool would be some kind of permissions proxy. I delegate access to a friend of mine. Maybe I can have an app that would say, you can only unlock my house between this time and this time. You can't do that through the standard system, but if I had some way of bolting that in front, I would totally be open to that, right? Like, so this opens up some options. One notable note from Halloween, my doorbell was completely useless, completely and utterly unresponsive. So we got 104 kids. Our doorbell rang probably 80 times over the course of 2.5 hours, which means that I got notifications thrice. What does your cloud provider do, or what does your service provider do if they A, suck at cloud and scaling, and 2, get in 3 orders of magnitude more volume for 3 hours than they're used to? Right? My doorbell rings 3 times a week, maybe. It rang 80 times in 2.5 hours, right? That's not just me, it's everyone else in the city with Vivint, everyone else in North America or anywhere that celebrates Halloween. I think Mexico does too, right? So anywhere that they're in one of those markets, this is impacting their load. I know some folks that also had Vivint, and they would get notifications saying your door is left open because the door closed event got lodged in a queue for too long somewhere, right? What happens if I come home, it's freezing, I wasn't planning for it to be that cold. I don't have a jacket. I can't unlock my house because there's too many doorbells ringing. Right? This comes down to the availability part of the CIA triad for security. Like, availability is an important part. In theory, your cloud service should be more available than anything you run on a Raspberry Pi. In practice, that's only true if they're good at what they do. And they have to be good at that part of what they do. They can be good at other things, like sourcing devices and making sure they all work together. But if they suck at scaling their infrastructure, that's something you have to keep in mind. But it's not something you can evaluate prior to signing the agreement. So if you're looking at one, talk to someone, find someone that has it, ask them. That's the best I can say. And by the grace, I'm done. That's what I got.